exercises in one example so you can see how it links from here and you get into exercise 9D. This is 9C. Okay. This is called a 5-number summary. So they call it 5-figure summary. Same thing, 5-number summary. What's the 5 numbers that you need? You need 1, the minimum. So I'm just going to write underneath here. 1, you need the minimum. 2, you need Q1. 3, you need Q2, aka median. 4, Q3. And 5, maximum. That's what a 5-number summary means. Okay, so all your data can be split up into these 5 sections. Here's a list of data they've given to you. They say for the following data set, the number of flying geese spotted on each day of a 13-day tour of England, so 13 days, the number of geese you see, you then write down the number, right? So there's 13 numbers here. They're all mumble-jumbled. What I've done is I've reorganized it for you, just in case you can't be bothered rearranging them. I've done it. So you can just copy this line for now. 2 1s, 2 2s, 2 3s, 2 4. I mean, 3 4s, 5 6 7, 18. Okay? Let's answer the questions. Number 1. Now that you've organized the data, what's the smallest number, which is the minimum? What's the minimum equal to? Let's go with Tig. What's the minimum? 1. What's the maximum? Can I please have Jack? 18. Very good. Too easy. These are the first 2 numbers that most students should write down first. And if I draw it on a number line so you can see, your smallest number was 1. So say it's here. I put a dot. 18. Let's just say it's up here. You put a dot. So the numbers must range between these 2, minimum and a maximum. The next one that you should find is Q2. It's the median. So that's the middle. How do you find the middle of 13 numbers again? So again, you can kind of try to estimate and then guess where it is. But there was a formula that I might have mentioned, or maybe I haven't. I might have told it to my year 9s and 8s. But anyone know the formula that you can find the median? No? Okay, we'll write this down then. So median, in your notes, there should be a row for median. It is n plus 1 divided by 2. It's just a quick way that we realized if you just add the number of numbers you have, you add it by 1, and then you halve it, that's where the middle should be. That's where it should be sitting. So how many numbers do I have? I've got 13-day tour, so there's 13 numbers here. If I add 1 to it, 13 plus 1 gives me a total of 14. 14 divided by 2, 7. So your median is not 7, but it's in the 7th position if you order it. So if I order it here, you can see this is number 1, number 2, number 3, 4th position, 5th, 6th, 7th, 8th, 9th, 10, 11, 12, and then 13th position. They're telling me the 7th position is where the median is. So this must be the middle. So the median must be 4. And if you don't believe in it, you can actually see there's 6 digits on the left, and 8, 9, 10, that's 3, 4, 5, 6. There's also 6 digits on the right. So this helps for you to find your median, whether it's even sets of numbers or whether it's odd sets of numbers. If you just use n plus 1 divided by 2, you'll know where the position is. Okay, so this is the 7th position. So now I know it's at 7. So 7, half of 18 is 9. So maybe the middle's around there, 9. So 7 could be maybe around here. I'm doing a guesstimate. I'm going to write it with a vertical line. I'll do a vertical line there. So that must be my median. That's Q2. So I'm going to write here Q2. This is my minimum. This is my maximum. Once I split the data into half, because median is the middle, that means 50% of data is on the bottom, and there's 50% of data that's above. Now that you got 50% on the bottom, 50% on the top, then Q1 tells you, well, what's the middle of the bottom half? Okay, so I've got, this is the middle, so that's the bottom half. This is the upper half. So if this is the bottom half, what's the middle of the bottom half? So here we go. This is my bottom half. What's the middle? I've got 6 digits. you can use this rule again. There are 6 digits on the bottom half. If you use n plus 1, 6 plus 1 is 7. 7 divided by 2. What's 7 divided by 2? It's half of 7. 3.5. Yeah, so that means that I know the median must be in the 3.5 fifth position. Where is that? Well, 3.5 is here. That's in between 3 and 4. So that's the position. That's where the middle should be. So if the middle is meant to be here, that's the 3.5 position. Q1 is between 2 and 2. Those are the two numbers that I'm working with. But the numbers between 2 and 2, it's just itself. There's no number between 2 and 2. It's just 2, right? So the answer here, Q1 is now 2. So I now know the middle is 2, and 2 is probably closer to this point over here. So let's do 2 there. I'll do another vertical line. That's my Q1. So I got Q1. Is that 2? 7 is my Q2. Let's go to now Q3, which is the middle of the upper half. We said it was 3.5, right? Because there's 6 digits here. So it's 3.5. That's 1, 2, 3. 3.5 must be between these two numbers here. Okay, so if it's between these two numbers, well, what's the two numbers? It's 5 and 6. What's the middle? 5 and 6? 5.5. So I now know Q3 is equal to 5.5. Wait, that doesn't make sense. Oh, my middle's 4, wasn't it? Why did I write 7? Oh, because 7th position. Sorry, my bad. That makes a lot more sense now. That means the middle should have been somewhere here. And 5.5 should have been maybe about here. 5.5. Does that mean I got the... What's this 9? Oh, that's the halfway mark. Okay. All right, team. So what I can see now is I've got 3 vertical lines. This is a box plot. If you put it all together, drawing a box together, that gives you that rectangle. The center is Q2. This is Q3. And then if you add in what we call whiskers, the minimum to the box and then the minimum to the maximum there, that gives me exercise 9D. So what I just did before, that's 9C. 9D illustrating it gives you now your box plot, and that's 9D. Okay, so I'm just going to draw that vertical line again because I somehow deleted it. What we can see from this data is that most of the data seems to sit closer to the 1, 2s, 5, 6. So really, this 18 looks a bit odd. Most of my data seems to sit in the single digit zone. That 18 could be an outlier. So in exercise 9C, you then check, is that actually an outlier? And anyone remember the formula for an outlier? If you don't, write it in the notes here. Outlier. How do we calculate the outlier again? There's a lower fence and an upper fence. Anyone remember the formula? Hands up if you remember. No idea? All right, cool. I'll tell you the formula here. This is 1.5. So Q1 minus 1.5 times IQR. This is Q3 plus 1.5 times IQR. Now, out of curiosity, anyone know what IQR stands for? And what is the interquartile range?
In this one?
Yeah.
It's the first quarter, isn't it? 3.5.
IQR is the range between Q1 to Q3. So how far does it take to go from this box, the width of this box, Q3 to Q1 to Q3? What's the distance? So you calculate that by Q3 minus Q1. Now let's think about it. Q3 is 5.5. Q1 is 2. What's 5.5 take away 2? 3.5. Now I asked this to one of my year 9s who is currently doing the year 10 methods textbook. in her own spare time, she was able to answer all these questions, but then when I asked her, what's an IQR? She's like, IQR is Q3 minus Q1. I'm like, great. Well, what does that mean? And then I gave her a question. I said, what if you had an IQR of 3.5 or 3, and then someone else had an IQR of 10? What's the difference? Why does it matter? Is it good or is it bad? And she wasn't able to answer me at that point. But after I explained what an IQR is, and when you think about it logically, then she was able to explain what it actually is. So I'm going to get you guys to think for a moment. See that box? The width of this box, which is what we're trying to calculate, that's IQR, right? Because you're saying this, take away this, that gives you the width, right? So that's IQR. But if you look at this data right now, what is IQR representing? If you had to look, because we use this for your NAPLAN test, your PAT test, and all that. What's the width of a box mean? So if you look at this data, what is that width representing? If you had a guess. The range of what? It is the range of Q1 to Q3. Q1 is 25th percentile. Q3 is the next 75th percentile. What does that mean?
The most common numbers.
Yes. I want you to think for a moment here. If you organize the data, smallest numbers here, maximum numbers here, 50th percentile, the median, you're just saying where the middle person is. So if I ranked everyone in an order, the person who stands in the middle is just the middle. But then you have a bottom half, top half. When you say the 25th percentile, it's the middle of bottom, middle of top. What you're really saying is, if you add it together, isn't that just 25 plus the 25? Because 25 to 75, it's 50%, isn't it? You're saying half of your data sits here. But that's not any half. It's the half where most people sit. If you think about it, if I drew a bell curve, see, this is the middle, right? That's 50%. You got a lower half, you got an upper half. But imagine if you took 25 to 75, that's still 50%. But isn't that most of everyone? Like your IQ is 100. On average, people have 100 IQ. So if you take 25% like that way and then 25% above, you got 50% of the population where most people are. That's what IQR is. IQR just means where's everyone roughly sit, right? So IQR is where everyone roughly sits. Now let's have a think about the lower fence and upper fence. Lower fence and upper fence. If I said Q1, where's Q1? Q1's here. This is where Q1 is. Why am I subtracting 1.5 times IQR? So let's think about the language. 1.5 times IQR. IQR is where everyone sits. Why am I timesing it by 1.5? What's 1.5? When you time something by 1.5, what are you really doing? What's happening? You're adding an extra half to it. It's like saying 150% of what everyone is. If everyone gets the scores about here, and then I said, let's beef it up by an extra 150%, right? Not by 200%, don't double it, but just by 1.5 itself. And can you see what they're doing? They're saying, all right, I'll beef it up. And then your lowest point, the person who's in the lowest end of where everyone is, I'm subtracting further. Can you see that? Have to think about the logic here. You're saying, at this point, that's the person who's the lowest of the average. And then you say, let's see how bad you can get. I'm going to minus by 150% of everyone. That's the average. You're 150%ing, whatever that is, and you're going further that direction. So you get this boundary. If IQR is already the average, you're beefing it up by an extra 50% on top of that, and you're going further to the left. Anyone who scores worse than that has to be so beyond where everyone should be sitting. That's why we call it the outlier, because you're so far beyond what we would have assumed you should be. If everyone's sitting here, and then we beefed up that range and we're into the negative zone, and you're still further than that, well, you must be really bad. True? So that's why it's called the lower fence. And then the same thing goes the other way. If Q3 is the upper end, if Q3 is here, and you're saying, yeah, the smartest person of the average is sitting here, and then you say, let's beef up the range. You say, all right, let's 150% this way. Of course you add it on. You add on 150% of IQR, and if that gives you an upper fence, and someone is still beyond that, well, you're way beyond what the average is. Okay, you're way beyond the average. That's why that's called the lower fence and upper fence. If you're way beyond that, you're an outlier. Or if you're way below that, you're an outlier. Now let's go back to the question I asked my year 9 student who was doing this herself. I asked her, if your IQR for one group was 3 and the other IQR for the other group was 10, what does that mean? Is it good or bad? What does it mean if I said an IQR is 3 versus an IQR that's 10? One is... Oh, no, that's about a certain point. Remember, IQR is the width of where everyone is sitting. So you either have a range of people that's around 3, or you have a range of people that's 10 units apart. What does that mean?
Does it mean like for IQR 3, like everyone's like relatively close together, and so like the average like there's very minimal difference, whereas IQR 10, like most people are getting like very nice.
So beautiful. And a lot of students, you can't see it when I write out the numbers, but if I drew a picture for you, it makes so much sense. See, if I drew a bell curve, I just love the bell curve because people seem to relate to it. But if I drew a bell curve like this, that would mean most of the people sit in this section. The width is very small. It's thin, right? So that's like a width of 3. But if I had a width of 10, then maybe it'll look something like this for the same area. So what does that mean? If you have a smaller IQR, it just means the range of people where everyone's sitting at is so close to each other. That's a good thing if I'm talking about tests. That means my class could range from the lowest person in my class could get an 89 and the highest person could get a 95. That's really good. Whereas if I had a wider range, even if I had a higher score, I could range, some kid could get 40 and then some kid could get 110. You know, it's like, well, I don't know. I generally prefer a smaller variability. That's actually much harder to do. Big variability is not generally ideal. You want more accuracy because then it's more predictable. That's what an IQR does. Okay, so it's not just Q3 minus Q1. We understand that mathematically, but what does it mean in general? And that's what we do in general maths. So when you do general maths, they don't go to this kind of theory. I'm explaining because you guys are in methods, but in general maths, you actually learn to interpret what's the numbers mean. And that's why it's exciting. It's interesting. Yeah? Anyways, so I gave you a bigger picture just now on what 5-number summary is, how to put it into a box plot, and I gave you the formulas for outliers. If you watch 9C, 9D, then it goes a bit more in depth and you have more examples to work with. But that's essentially what you learn for this week. Okay, so statistics leading more into general maths. That's what you're going to be doing. So 5-number summary. You got a box plot. How do you do it and what does it mean? That's probably the more important part. Okay, so it's not just the how. It's why do we do it? Why does it work? All right, I'm going to stop the video here.